Electricity Production from Waste and Biomass by John Kosnick, Tyler Oakes, and John Strannon. What is a biomass? Biomass is defined by dictionary.com as an organic matter, especially plant matter, that can be converted to fuel and is therefore regarded as a potential energy source. We will be dividing this topic up into two different types of biomass. The first being plant and crop biomass, and the second being animal and landfill waste. For plant and crop biomass, plants absorb and store energy from the sun in the process of photosynthesis. Once plants are burned, they release this stored energy in the form of heat. This heat energy can then be used to power steam turbines to create electricity, as seen in the picture below. For animal and landfill waste, animal waste can be collected from farms and put into a container called a digester. Bacteria is then added into the digester. As bacteria eats the waste, it begins to produce methane gas. This methane gas is then collected and used as fuel to power steam turbines to create electricity. In a case of landfill waste, a similar process is conducted, where a section of a landfill is closed off and confined. Then pipes are used to transport the methane gas that is produced from the decomposing trash of the landfill to be used as fuel to boil water into steam to power turbines to create electricity.
Combustion is one of the most common ways that biofuels are used for power output. Based on the types of biofuels that are used, sometimes there needs to be a preparation process before that they are applicable to certain power plants. Some of the biofuels need to be dry, they need to be resized, they need to be densified, or they need to be transformed. Thinking about wood shavings, wood particles and whatnot, densifying compacts this biomass so that it's usable in a combustion furnace. Based on the power plant schematic shown, the biomass enters the combustion furnace and is combusted, and then that heat supply heats the gas into a steam, and that generates the power throughout the steam turbine. In terms of excess heat, the power plant can be used as well for not only electricity, but a heat supply. And based on what we found, wood biomass, which is commonly used, has a power output of about 6 to 8 megajoules per kilogram of biomass. Co-firing is another type of combustion process that uses 2 or more types of fuel. In our case, there's direct, indirect, and parallel co-firing. Direct co-firing uses biomass and it is burned directly in a coal furnace with coal. Indirect is using biomass but in its gasified state and combusting it in the coal furnace. Parallel is when the biomass and the coal are burnt in separate boilers and then joined later. Although biofuels can reduce the amount of CO2 emissions by pairing them with fossil fuels, biofuels also release methane gas.
Anaerobic digestion is the process of solid biomass being turned into a synthesis gas through decomposition by bacteria. It takes part in 3 main steps. It's initially broken down into the sugars. It is then converted into carbon dioxide, hydrogen, ammonia, and organic acids. And then finally, it's converted into methane and carbon, which are used as the power source. In addition to this, nutrient-rich byproducts are also produced that can be used for other things and put back into the soil and whatnot. Typically, this process will yield about 20 to 40% of the heating value as compared to using feedstock. Gasification is another method of turning solid biomass into a synthesis gas that can be used for power, although with this process, you heat the biomass at extremely high temperatures, usually 800 to 900 degrees Celsius, and it's then turned into gas through partial oxidation. This will typically yield approximately 4 to 6 megajoules per newton meter cubed in caloric value of the gas. And then that gas can be used either in a conventional boiler, used to power turbines to produce electricity, or used for motor power. When using the biomass for different processes and different goals, it'll yield different efficiencies. When you use it as a heat source, you'll typically get an energy range or an energy efficiency of 75 to 80%. When used to generate electricity, you'll get a much lower efficiency rating, usually about 20 to 25%. And then this compares to coal and natural gas electricity generators, where it's typically about 30 to 40%, which is a little bit higher than the 20 to 25%.
Although the implementation of biomass in co-firing combustion can be expensive, there are some benefits. Biomass is more abundant than fossil fuels. It's a renewable resource, similar to fossil fuels, but the maturity rate of trees can be anywhere from 10 to 15 years. It is cheaper to produce, and the CO2 emission is much less than burning fossil fuels. Although biomass produces methane, the drawback is much better than burning fossil fuels.